Yes, my name is Dave Arendash. I work out of the Liquid Studio in Redwood City, California for Accenture. And I'm on the wearables team. I've been at Accenture for about a year and a half. I've been in augmented reality since 1986, roughly. How many people remember what an Amiga computer is? All right. Oh, pretty good crowd. All right. Yeah, that was an amazing machine, and that was my first foray into augmented reality. It wasn't even called augmented reality back then. But fast forward to the present, and we've got a whole bunch of cool new toys. So today we're going to look at pretty good overview, I think, of what augmented and mixed realities are, various types, some of the technology, and some examples. And why? Why now, right? So business cases, they always want to know money. So the Juniper folks figure $2.5 billion in the next few years for instructional training, brochures, et cetera. And that's kind of the ask that we've been getting at Accenture is largely training. But a lot of people may recognize AR as being the Pokemon game, which was very famous last year. But you may already have Google Translate in your pocket. I know that it's been helping me get through Europe quite nicely. That's augmented reality. Anyone who's watched sports on TV has probably seen some sort of augmentation. And driving your car. You can get driver-assisted directions, etc. So, like most technologies, there's sort of a hype cycle. And you can see that there's AR 2016 that puts us right about here, which means that a lot of the hype has already happened and a lot of the reality has set in, that it's not what everyone hoped it would be. What happened to Magic Leap anyways? Where's my Magic Leap? As time goes on, it's going to find its place in the world. And VR is already climbing that scale. Market trends here. I'll let you peruse that on your own here. There's a lot of small print to get through, and I've got a lot to get through. So some of the players involved here, this is largely some hardware people. They mentioned Magic Leap. I'm not sure how long they're going to stick around. We've got a HoloLens here we'll be showing you some stuff with. And I don't know, some of these players probably familiar to already, Google Cardboard, etc. So we'll take a look at some smart glasses things here. And the difference between smart glass experiences, right? So there's what we're calling assisted reality, which is kind of a flatter look of AR. Augmented and mixed reality, which is more like the HoloLens, where you put on something, you have a binocular view of the world and 3D objects in it. And that contrasts with virtual reality, where the real world has been replaced by a synthetic one. And so, again, this is assisted reality is sort of a HUD, right? A heads-up display. It's going to assist you in driving or in getting some work done. We do a lot of things with workflows, right? So someone needs to go out and repair something. They'll have the schematics and maybe some tutorials. They can do a two-way video conference call with an expert to get help. Augmented and mixed, this is again more the HoloLens thing, where the device is more spatially aware of its surroundings and is able to place things in the real world to help you out. So instead of it just floating in front of your head wherever you're looking, it puts it right on the part. So if you're working on this thing, you'll see parts here, and as you move around, they're still apparently floating in space with you to give you more accurate positioning of the information. And virtual reality, again, is completely immersive, and a large FOV is essential for that sense of presence. And right, so assisted reality, we've listed here the Google Glass. Obviously, not everybody's wearing Google Glass the way they thought it would. It's still around. They have an enterprise version of it, but it's a very niche markets. Augmented and mixed, so there's a HoloLens and these ODGs. Sorry, the ODG is doing a lot of nice work. It's sort of a HoloLens Lite Android system. Not as advanced as a HoloLens, but it has its place, mainly because they're more industry-ready, ruggedized. And then a lot of this virtual reality stuff, which we're just going to kind of gloss over. That said, I do have some things to show you with virtual reality, too, towards the end. So in this assisted reality case, again, sort of a workflow thing. This is things we do with a system called Skylight, wherein a dashboard is used to define a workflow with tasks and subtasks. There's audio, video, imagery, whatever, to help get the context of what the worker is doing. It's very customizable, situationally aware, can provide information, and it reads barcodes too, right? So whatever you're doing with, if your machinery is, coded, then the sensor knows exactly what you're looking at. So think cable boxes. They have barcodes, and you know exactly which cable box you're looking at. Whole bunch of benefits, all the good stuff: increased safety, lower costs, less downtime, et cetera, et cetera. We find actual metrics on this is, I guess it depends on the task, but anywhere from 30 to 70% improvement in performance of humans being assisted this way. So the more binocular stuff, which is, again, the Meta, the HoloLens, et cetera, what we're doing with this, we did, these are things that my group has been involved in. A healthcare app, so I don't know if you can make that out there, but that's a guy on a table, right? And they're using a medical sensor that's tied to the HoloLens, and they're also talking to the doctor. The idea would be that this would be something used in an ambulance to, get more information and help the emergency medical tech, triage the patient before they get to the hospital. There's some electrical, I guess you'd call it, yeah, it's a breaker box for electrical, whatever electricians do, right? They get power around, and they don't want to blow up the place, so they train them on how to do this tricky stuff. It's more than just a fuse box like you'd have in your house. This was a POC we did last year at the Farnborough Air Show, and we basically had it was sort of a road show, right? So we didn't have an airplane there. Bombardier, makes airplanes. We didn't have one to practice with, so we made this entire system that allowed us to place this holographic information around it, and led people around a tour of the airplane, including walking through a full-size fuselage and being in the cockpit and looking at the engine parts and so forth, all holographically. And something we're working on is this workflow engine, which is basically the same idea of assisted reality, but instead of it just being a HUD, is really now more of a holographic experience that can be outfitted over the internet with, again, all the same benefits. Okay, pardon me a second. So we'll look a little bit more into what it takes to make augmented reality. Augmented reality is basically machine awareness, right? It uses vision, so whether that's a standard camera or like in the HoloLens and others, there's depth cameras, which actually use something you could think of it as LiDAR. And sometimes it actually is LiDAR. Various techniques to get the three-dimensional awareness of a space. A lot of times augmented reality uses markers. Sometimes that's 2D, sometimes that's 3D. You can actually have a 3D object be your anchor into the digital world. GPS and other location services can be used. You provide, again, situational awareness, or in the case of driving instructions, you can see like on the horizon that, oh, that's where I need to go. IMUs, inertial motion units, to know where your head is positioned and where the device is positioned if you're using it this way. And external tracking can be used. The STEM, I mentioned this because a year or so ago it looked like it was going to be a big deal, is a wireless tracker that is a 6-degree freedom tracker that you can have up to 5 or 7 modules on it. So you can do all sorts of interesting things by having things in your hands, mount one on your head so it knows where you're looking, and can provide room scale virtual and augmented reality support. MoCap, as motion capture, we'll see some examples in a moment, and room scale tracking. You've probably seen these at trade shows where they have cameras all around an area and people walking around perhaps with ping pong balls on them to capture their position in space. We'll see some examples of that. So again, these image markers, they've started out very simple. This was like 10 years ago or so. And now everybody supports also image markers. So these can be as interesting as pebbles, but more likely are going to be something that's product based. So these are for doing things like brand awareness and user engagement. Lots of basically games and toys using that type of a thing. You can have multiple markers. So you could hang these markers on walls so that anywhere you look, you're seeing one or more of these markers. And detecting any one of those markers will let the system know exactly where you are in relation to that marker. If you have enough of these around the room, you can do room scale tracking or tracking throughout an entire building. You'll never get lost, right? So indoor navigation can be made possible with this. And in 3D object tracking, these tend to be on smaller objects, not giant airplanes. Things that are interesting looking. Things that are symmetric, like this has a radial symmetry to it, make bad markers, because from any angle it's the same, right? So a key to choosing markers is that they are somewhat asymmetrical and that any given view is unique. This is true with imagery or the 3D. Edge detection can be used. So in this case, computer vision algorithms find high contrast in the picture and know that that is the edge of something. And again, the algorithms just are able to segment that out and know, for example, that this is a cup and that this is a marker and that's a monitor and so forth. These can be pre-programmed. What generally happens is you upload a picture to a service like a Vuforia service. It does the analysis and brings it back into your device. But there are also some systems which are field programmable, which means if I wanted to outfit this room with AR markers, I could go around and take pictures. The service does it real-time processing and adds it to its image database so that it knows exactly where I am, and I can build that experience sort of on the fly. So that leads us to how do these things work? You can use onboard processing. So most modern phones are very capable of recognizing maybe 50 to 100 different markers at a time. You don't need connectivity to the internet for this to work, but again, there's sort of a limit to about 50 to 100 different things. Cloud-based, on the other hand, uses basically a video stream out of your device, does the recognition in servers on the cloud, and pulls out the data, sends back the information, the pose information of where you are in relation to it. The upside is that that's an unlimited option. You can have millions and millions of markers. So imagine the entire Louvre, and every painting is its own marker. On the other hand, it requires Wi-Fi, and hopefully that is Wi-Fi, not your data plan, because you're going to eat through your data plan very quickly. And there's a lag to it. So as we'll see, especially in virtual reality, but also augmented reality, if there's lag, if you turn your head and the image doesn't follow exactly, you start to get a headache or a little dizzy. So we need to make sure these things are very performant. Another type of augmented reality is facial feature recognition. You've probably seen these makeup ads where you can try on different makeup. Of course, Snapchat, you can put your dog face on you or whatever. These are getting pretty good about recognizing mouths and eyes and so forth. And you can replace your face with another person's face. Combine this with AI, and actually not just lie detection, but mood detection, more accurate than people, has been achieved. So imagine airport security, they're screening people for nefarious motives, can just look at the camera, and it knows whether that's a concern because I'm worried about flying, or I'm worried that they're going to detect the bomb in my suitcase or something. More likely, it's going to be some makeup ad. We've had more asks for cosmetics than for security, thankfully. Eye tracking is another thing that's becoming a reality. We just got a FOVE, F-O-V-E, headset. It's like an Oculus Rift, but with eye tracking in it, which is an amazing improvement. When you have a headset on, it knows where your head is pointing, but it doesn't know where your eyes are pointing. So if you're using the tracking to, for example, know what people are looking at in a retail environment, they say, okay, are they looking at the cereal or are they looking at the dishwashing liquid? Great, but where are they really looking? With eye tracking, you can tell that and get metrics on that. Great for marketing, but for the experience itself, it also means that you can tell if they're trying to look at something in the distance because their eyes are straight ahead, or something close up because their eyes are a little towed in, right? And with that, you can change the rendering. So now you can blur synthetic objects in the background or in the foreground, depending on where they're looking, for a much more realistic, immersive experience. Sorry, yeah, so eye tracking for the movies here. Another component is simultaneous localization and mapping. That can be done with computer vision and standard cameras. It's not quite as good as using depth cameras. HoloLens, the Meta, Tango, and, well, the Kinect camera is a depth camera, etc. Again, this is where it actually reads the depth of everything it sees and can build up a point cloud. Point cloud can lead to a mesh, which is the connection between those points. And when you have that, you can also get the surface orientation. So I know that this is flat towards the sky, and that that's flat towards the ground, and this is flat towards this way. And curved surfaces are pointing whichever way they point. That gives us much more realistic rendering, but it also lets us know what's, where our gaze is. If it knows now that I'm looking at a wall or the floor or whatever, and that can be used again to create whatever experience you're going for. The model that it builds doesn't have to be seen, right? So as you hopefully will get a chance to look in the HoloLens, there's a visible model that gets built, and you can see it like when you tap like this sort of spider web. You can see the model, but most of the time it's hidden. And it's there for spatial awareness, but it also is there to occlude things so that if for example, I'm standing here, I can't see through this table. So if I have digital content on the table in front of the surface, I should see it. But if it's below, down here, I should not. And so the 3D model that it's built of this table will hide that from me, and it gives more realistic experience. So I don't have X-ray vision through the table. Camera tracking is another form of augmented reality, and this is where they've got sensors to positionally track the cameras. This is used in commercials, movies, sporting events. So that as the camera moves around, they know exactly where to place the augmented content so that it looks like it really belongs in the scene. And a famous example of this was what Cameron built to do Avatar with, and is becoming very popular with movie making now. They can do their special effects in real time as they're making the movie. Motion capture, yet another form of augmented reality. In this case, we have someone usually in a suit. This guy, that guy. And there's the points that it's falling on all the joints. 3D character follows that, and then actual characters are mapped onto that skeleton. Okay, what kinds of displays? What have you got in your pocket, right? So it can be as mundane as a cell phone or a tablet. We can have binocular or monocular eyewear. And so, again, HoloLens is just the most fun. I don't work for Microsoft. I just love the HoloLens, so I'll keep talking about it. But so with the monocular, obviously, it's just in one eye. It can be see-through, as in Google Glass, or it can be not see-through, as in the Vuzix or others, where you're basically just looking at a little monitor here. And there's usually a camera on the other side of that that can bring the image through. Very important, because real world and synthetic world should line up, otherwise you may get a headache. With the see-through binocular vision, like the HoloLens, the ODGs, etc., that's not an issue. There's also the no-glass auto-stereoscopic displays, Flight Depth tablet being one of those. It doesn't actually look like that because this part wouldn't be seen. It would just be whatever's in the rectangle, of course, but that's hard to vision without actually having one here. Uses lenticular lensing or a visual barrier over each subpixel of the image to let either your left or right eye see a sub-image. Not very popular, unfortunately, but I think its time is yet to come. Other types of displays are projection, right? So in this case, they're projecting the medical image on top of the skin. And then there's a company called Cast AR, and this is a very fun thing. These glasses here are actually projectors, right? There's a pico projector above each eye that projects left and right images out into the world onto a retroreflective surface. So in this case, it's just this matte, but it could be everything in the room. You can sort of spray paint retroreflective coating on everything, and everywhere you look, it reflects back to you. So it has a very realistic representation. It looks very much like the HoloLens, but it's very lightweight and a unique experience because you're not looking through anything. It's literally bouncing the image back to you. So hopefully we'll hear more from those guys. All right, how do we make this stuff, right? So what's the software end of it? Right now, the main way to build this is with game engines. So Unity and Unreal are the two most popular, and Unity is probably the most popular game engine technology. You can download it for free and get going immediately. There are web-based solutions as well from Wikitude, PTX, and several others, where you basically create a generally free account, and you can get started right away. Sometimes these will build directly to your device, and sometimes it's more of a cloud build. These are some of the players in the AR landscape, so I was hoping that you could all get these slides later. There's very many of these in here. So applications, tools, devices, inputs, outputs, all these things. Many players in the space. I'll let you peruse that at your leisure, as well as this one. This is an overview of SDKs available. There's 3 pages here of just this one. comparing all the different things here, like which OS they run on, whether it's Unity, marker tracking, mobile, web, PC, 3D, GPS, facial tracking, etc. It's a very nice reference. And some of the more popular ones that we've used, my team uses Unity almost exclusively, has been the Vuforia one is probably the #1. Metaio was up there, and then they got bought by Apple a couple of years ago, and we've not heard from them since. And if anybody here is from Apple and would like to tell me, I promise I'll keep your secret. I would love to know what you guys are doing over there. Wikitude is another one that's sort of up and coming. Daiquiri, we just got one of their helmets. It's essentially a HoloLens in a helmet. Cost 5 times as much, and it's not quite as powerful, even though it does have a nice infrared camera in it. But it is hardened for industry, so hopefully we'll see that gaining momentum here when it gets approved in June. A few other toolkits here. So lots to choose from when you're building your apps. So I'll take a moment here to talk about a few use cases. A lot of times it's just little toys for promotional gimmicks and so forth. We use, again, for the enterprise, it's a lot of this over-the-shoulder coaching type of thing. Factory automation, we've done stuff with various types of factories. I shouldn't say who, but you can get telemetry through the Internet of Things and have that data overlaid on your tablet or your eyepiece. It works out in the field sometimes. In this case, we're overlaying mining data. Where is the ore, right, in this big pile of blasted material to help them, sift through the rubble and get to the money. And where is it going? Well, today, that's kind of where we're at. And I have to say that this slide is about a year old, so we're actually a little bit further down the curve here. This HoloLens stuff is now, it's been out for a year. And we're kind of doing that with it. It is a dev kit, so we're not really deploying this to any serious industry, except as proof of concepts, essentially. As Bobby Orr, great hockey player, was asked, how are you so good? He said, I skate where the puck is going to be, right? So that's what we're trying to do. We're skating to where the puck will be in a year or two, and we'll be there when the equipment is ready. This is, Magic Leap. Again, this is an old slide. I don't know if you've heard Magic Leap has been having some troubles with credibility and infighting. So we'll see where they go. This slide here actually says a lot if you've seen this video. There's all these kids here oohing and aahing about a whale jumping through their auditorium, but none of them are wearing headsets, so how do they see it? I don't know. But this technology, with or without Magic Leap, is on its way. And what does it mean? Far more realistic rendering right onto your retina. If you focus close, things in the background are blurred. If you focus far, they're not. It uses a light field technology to make this display. And of course, that can be completely augmented as well. And maybe in 10 years, we've got contact lenses. People are working on that. I know that there's some people talking about implants. I don't even want to talk about that. I don't want Russian hackers in my head. If I can take those contact lenses out, I'll feel better. And so I'll talk a little bit about Accenture and our team, some of our capabilities. So we use this Skylight for doing assisted reality, and we also have ASOP, that's sort of our own version of Skylight for doing hands-free training, inspections, etc. Augmented mix, so we're basically doing a lot of custom stuff. Again, POCs, and we may have a pilot going here soon. For virtual reality, we do a lot of, again, custom work. We're looking at VR analytics, commerce, et cetera. And we've just done some 3D production. So what does that mean? It means show and tell time. This is a camera I actually built before I came to Accenture. And people ask, how do you record virtual reality? It's going to be something like that. So what this is a cluster of 13 GoPro cameras, right? We've got 6 stereo pairs all around and 1 pointing up. Almost never really need a down pointing camera, except when we climbed up that tower in Amsterdam last year. We attached an additional camera and climbed up a 150-meter radio tower to see what that would look like. Short story is vertigo. But I've used this for doing tourism and so forth, and we hope to use it for, again, training, HR, onboarding type of training, as well as, who knows, insurance companies or medical training, whatever they want to do. But this will put you in a moment in time like nothing else. The fact that it's using stereo panoramas is far more immersive than other technologies out there, which are just using a single spherical thing. And without depth, you lose a lot of that presence. So I'd be happy to show you some examples of this. I have it on my phone, and I always carry my own little HMD with me for that. So see me after this or at lunch or whatever. I'd be happy to show you lots of content on that. Recently, okay, here we have AJ. So this is time for me to take a little break and let my coworker explain a little bit about what we do at the Liquid Studio.
The Accenture Liquid Studio in Silicon Valley is a purpose-built facility for the new IT. It's here that teams sit beside clients and vendors, perform design thinking, and execute everything from rapid proofs of concept to masterfully architected production systems.
These systems change the way we learn, do our job, and shop. AR provides contextually relevant data in a hands-free environment. This enables workers to be more productive, more efficient, and understand the data around them. Augmented reality can even be used to create a richer customer experience and increase sales. Let me show you.
The Accenture Mixed Reality Workflow Engine is the instruction manual of the future. Using Microsoft HoloLens, it's able to sequence any work procedure to show someone how to perform a task using arrows, circles, and other visual indicators. It also includes references to existing 3D models. The MR Workflow Engine is an example of how mixed reality can be used to increase learning, decrease errors, and build better products. Mixed reality can also be used to better understand data in the world around us. Fully informed by live IoT sensor data, mixed reality can help workers, such as aircraft engineers, to see how an engine is performing. Mixed reality also excels at creating immersive sales and marketing experiences.
We did a walk around of an aircraft where participants can stop at any of the 8 stations and learn more about the nose of the plane, the wing, the engine noise that's produced. And what they're seeing in a mixed reality device like HoloLens are virtual objects that they can interact with. That's the exciting part. You know, there's been augmented reality glasses in the past, smart glasses and so forth, but users can actually click on elements. They can play videos, hear sounds, and drive the experience the way that they see fit. And that's what's really exciting about HoloLens.
Augmented and virtual reality gets a lot of attention as the technology of tomorrow. But Accenture's wearable technology practice is using it to bring real benefits to our clients today.
Thank you, AJ. And another little quick video, this one from the Tech Labs, where they took a Meta, like sort of, you can think of it as a tethered HoloLens to an event to see how it would perform. right. So let's see, I'm running out of time here. I'll just gloss over this as a particular case where we did some smart glasses stuff. Oh, I am done. Okay. So yeah, again, just sort of the assets that we have. We've got actually this is an old slide. We've got a lot more fun hardware at our disposal now. So if you're interested in working with this type of stuff, please find me or anyone listed in the Accenture wearables group. We'd be happy to talk to you about building a proof of concept or pilot for you. And that's it. I think do we have a couple of minutes yet for questions? Yes, we do. Okay, great. Any questions? Would anyone like to try a HoloLens? Dun, dun, dun. So hopefully we'll have one of our actual demos of that jet engine set up outside. Folks from Avenade were very generous in that they've got a couple of HoloLenses too. So feel free to just go around the corner here and check that out. And you can try this one. We hope to have the jet engine demo set up. The gist of it is you look at the jet engine as you're a jet engine maintenance worker. You put on the HoloLens, you log into it, it knows who you are, it knows where you are. When you look at the jet engine, it knows which engine you're looking at and brings in the stats and the necessary instructions for that engine today, in which case it'll be an oil change on this engine. So the HoloLens then leads you through the procedures to open the thing and go in and where to operate and track your progress. So with that, if there are no questions, I will hand it back to Tico.
Okay, thank you.
Thank you.